Hi everyone, we are Team ghosthub. In this presentation, I will introduce our Pac-Man project. Before we start, let me show you what we are going to talk about. Firstly, we will briefly introduce the two technologies used in our group, heuristic search algorithm and game theoretic methods. After that, we will describe the performance of offensive and defensive agent in combination with actual demos. At the end, we will summarize the challenges encountered in the entire project and what can be improved in the future. We use heuristic search algorithm as our best AI technology. For each agent, we use the heuristic function above for each step of actions to define our next move. Besides that, the agent's choice of action is driven by 7 heuristic functions. In the final version of the project, there are 4 heuristic functions that are shared by both agents. Offensive agent has 1 more unique heuristic function, while defensive agent has 2 more. A specific process and demo will be discussed later. Then, game theoretic methods are used to help us improve our winning rate. In the game rules of this project, the more food we bring back, the higher score we will get. Next, if we assume all teams have the same performance, from the table we can see if Team A takes a pure strategy, then there is no doubt that they should have an offensive strategy. On the premise that Team A has such a strategy, Team B should also tend to be aggressive, otherwise the score will be 0. All in all, in this case, the Nash equilibrium is that both teams choose offensive strategy. Therefore, we choose the mode of double attack at the beginning of the game. At the start of the game, both agents are in offense mode according to the game theory we discussed above. Two agents use the same offensive at home heuristic, except two agents will go up and down separately to increase the attacking efficiency and avoid being discouraged from passing the midline at the same position. After passing the midline, the agent could have 2 modes. If the agent do not find any enemy around, it will try to eat as many food as it can using offensive arrow not enemy heuristic. However, if the agent detects enemies, it will switch to offensive arrow has enemy heuristic and try to find any existing capsules. Another scenario that an agent will find a path to eat the capsule is when teammate is being blocked by defenders. For some maps or situations, there is not any existing capsules. The agent that encounters with the enemy will find the shortest path to home, which is the go home heuristic. Agents will come back home when they eat at least 28 food as well. The difference of two agents is on the defensive side. When there is one enemy in our territory and a certain number of food has been eaten, the defensive agent will first come back and check the enemy by the last eaten point. However, the offensive agent will not turn into defense until the defensive agent finds the enemy. The defensive strategy is intended for increasing the success rate of defending, because it does not help to let two agents follow the same enemy. If our team has a clear lead, two agents will turn into defense patrol mode, which patrol at the midline and seek for enemy if necessary. There are a number of challenges we experienced in the entire process. Some are solved, but some are not. For example, the competition will be conducted on different unknown maps with completely different layouts. So in some cases, our game theory will not work by some map that is suitable for defending. Second, the dead-end problem. The biggest problem for attackers is the dead-end problem. We should avoid entering dead-end when there is enemies. We solve this problem by constructing a dictionary that contains useful information about dead-end, and then decide if we can survive after entering the dead-end. Third, it's hard to configure proper heuristic functions. We learn this from the results of pre-competitions. Finally, it's important to have a good understanding of games in order to generate accurate decision-making strategies. there are some challenges we haven't solved. In this game, the defender is in a relatively weak position, so it's difficult to defend. Although we implement the defense strategy that two agents do not come back at the same time, there is still times two agents would follow the same enemy. Another important point is about the eating speed. As we have two agents, it's hard to make them cooperate perfectly when eating the food. Sometimes two agents would have repeat routes which decrease the speed of eating food. Although we try to solve it by driving two agents to two directions, the problem still exists in some cases. Finally, about the future improvement, we believe we can improve our algorithm by combining our AI technologies with our heuristic search in some situations. For example, multi-color tree search can be used to simulate next few steps for the dead-end problem and simplify our algorithm. Second, the Q-learning can be used to shape the ways by learning from games and experience. So that's it. Thanks for listening.